Lesson 9.2 on the converse of the Pythagorean theorem. We just got done talking about the Pythagorean theorem in the last lesson. To review, the Pythagorean theorem says that if a triangle is a right triangle, then the sum of the squares of its legs are equal in area to the square of the hypotenuse. In other words, if we were to label this triangle's legs as length A and B and its hypotenuse length C, then a squared plus b squared equals c squared. As long as the triangle is a right triangle, then this equation holds true. But on the flip side, we also have the converse of the Pythagorean theorem. And remember, converse is where you actually take the if and then portions of the theorem and actually change them. In other words, in this case, if the sum of the squares of two sides of a triangle are equal in area to the square of its third side. So again, let's take this triangle, label its legs A and B, and label its hypotenuse length C. In other words, if we're given a triangle where a squared plus b squared equals c squared, then we can conclude that the triangle is a right triangle. So let's compare these two theorems just for a moment. The Pythagorean theorem itself says that if a triangle is a right triangle, then a squared plus b squared equals c squared. While the converse says that if any triangle has a condition where a squared plus b squared equals c squared, then the triangle must be a right triangle. For example, let's say that we were given the following triangle and we were asked to determine if it was a right triangle. So here we have a triangle with legs of length 6 and 10 and hypotenuse length 14. We know that if this is indeed a right triangle, then a squared plus b squared must equal c squared. So let's run those calculations. Let's say a is 6, so 6 squared is 36. Let's say b is 10, so 10 squared is 100. And let's say c is 14, so c squared equals 196. Now, do the math. What is a squared plus b squared? 36 plus 100? Well, that's 136. Definitely not 196. Therefore, it's not a right triangle. On the other hand, let's study this problem for a moment. Another triangle. Don't know if it's a right triangle or not, but we know it has legs of 5 and 12 and a hypotenuse of 13. So, let's say a is 5. 5 squared is 25. Let's say b is 12. 12 squared is 144. And let's say c is 13. So 13 squared would be 169. In this problem, do the math. 25 plus 144 is 169. Therefore, this is an example of a right triangle. This leads us into a good example of what's called a Pythagorean triple. A Pythagorean triple is a set of three positive integers. Remember, integers are whole numbers that are a solution to the Pythagorean equation. The most popular and well-known Pythagorean triple is the 3, 4, 5 right triangle. Bar none, no other triangle has been studied throughout history as much as this triangle has been studied. Other common Pythagorean triples would be 5, 12, 13, 8, 15, 17, and even 7, 24, 25. And there are many more examples than these, but these are the four most commonly referenced Pythagorean triples. Next to these, if we were to take any of these Pythagorean triples and multiply them all by a multiple, let's say that 3, 4, 5 triangle. If we multiply 3, 4, 5 all by 2, we get 6, 8, 10. That is also a Pythagorean triple. And any other multiple of the 3, 4, 5 triangle. Multiply by 3, we get 9, 12, 15. Multiply by 10, we get 30, 40, 50. These will all satisfy the Pythagorean equation. In addition, we could have multiples of the 5, 12, 13 triangle, double everything there, we get 10, 24, 26, 24, 45, 51, or even if we take all the multiples and divide by a multiple, 7 divided by 10, 24 divided by 10, 25 divided by 10, that's still a Pythagorean triple. Thus concludes today's lesson.